geometries becomes easy, as well as OBT concept becomes very easy. If you are not unable to understand this vector concept by absenting that and all, you may not be understand the 3D. Completely three-dimensional means we are going to represent the three-dimensional like plane equation, okay, and line equation in 3D, okay, with help of vectors as well as with help of coordinate system. So finally, if you want to understand the three-dimensional, you must have complete idea about the vector concept. Clear? See, the quantity which involves magnitude and direction, then the quantity is called a vector. Okay, and let us see some example. You already know all this example. Anyhow, once again, I'm going to write all the example. Like let us take time and money and work and speed and temperature, and you can take some length, area, volume, okay, and you can take distance, and you may take a resistance, any other, okay. So like these are the example of scalar, like sometimes degrees. Degree, if I take, if I say like 30 degrees, 30 degrees in which direction? If I mention with respect to x-axis or with respect to y-axis particularly, so that I having direction. If I write simply for 30 degrees or 40 degrees like that, it is not a vector, just it is a scalar. It has having only magnitude. And coming to the
Sir,
next one.
sir, a degree, is that like a temperature degree or like radian degree?
Yeah, it may be like radian degree or whatever it is. It is just a real number. Okay, degree
But
is
sir, if
simple.
it's like minus or positive, that can like determine the direction of the degree.
So minus means, for example, minus 30 I'm taking. Minus 30 with respect to which axis?
X-axis.
No, I'm not mentioning here x-axis. If I'm not mention anything with respect to x-axis or y-axis something, just it is a scalar. If I mention with x-axis, it will be becomes a vector. It has having some direction. I'm not mention anything here. So simply it is a scalar. Clear?
Yes.
Yeah. So coming to your vectors, the example simply add displacement and velocity and acceleration and work done, and you may take weight, and yeah, these are the few examples for uh, vectors. Okay, few examples for vector. So because here some see classify the following whether a vector quantity or scalar quantities. Then can you tell me what about this time period? Is time period is vector or
Scalar.
scalar? Yes,
Scalar.
scalar. What about distance?
Scalar.
What about velocity?
Vector.
What about work done?
Scalar.
Work done. Is it? In which direct only work? If you take only work, it will be a scalar, but work done is belongs to vector. Okay. And what about force? Force is also one of the example of force in which direction? Okay. So that is it has having particular direction, we require particular direction to move it. So force is a vector. So C student, time, period, time, distance, these two are scalar. Yes, yes. Vector, vector, vector. Got it? And coming to, okay, second question is that, classify the following measures as a scalar or vector. Yeah, anyone students, what about this? First 10 kg.
Vector.
10 kg means it is a weight. Okay, weight, vector. But what about second one? Is the direction, whether they have given direction or, yeah, northeast, clearly they have mentioned the direction, 2 meters northeast, direction is there. So vector. Then what about 40-degree?
Scalar.
Scalar, because with respect to x-axis, with respect to y-axis, they do not given anything. So it is a scalar. Words, 40 words.
Sir, scalar. Sir, vector.
Scalar only, 40 words. Yes or no? Students. Then what about this 20 meter by second square?
It's vector.
It is clearly vector. Okay. Then what about to 10 to the power of minus 19 coulomb? Students.
Sir, it's a scalar.
Scalar or not? Remaining students.
Sir, I think ampere is a vector, but coulomb is a scalar.
Yeah, clearly it is a scalar quantity. 10 to the power of minus 9 is a scalar quantity. Yes or no? See here, first one is 10 kg. 10 kg is scalar quantity because it involves only magnitude. Then 2 meters northeast is clearly a vector quantity because it has having both magnitude and direction. Coming to 40 degrees, you have to write like this. 40 degrees is a scalar quantity. It involves only magnitude. And 40 volts. 40 volts is a scalar quantity. It involves only magnitude. And next one, 10 to the power of minus 9 coulomb is a scalar quantity. It involves just magnitude. And 20 meter per second square, it involves both magnitude and direction. Clear? Like that.
Sir,
Yeah.
sir, how 10 kg is vector, sir? It's only mass.
Yeah, sorry. Yes, work done is like actually work done is a scalar quantity, not vector.
Sir, 10 kg in the second question,
Ten-
first option.
10 kg. Okay.
Yes, sir. It is only mass, no, sir.
Okay, 10
Force only
kg.
means it is a
Right,
vector.
10, yeah, 10 kg, right. It is a scalar. 10 kg is a scalar, which these are all, I think so, it is belongs to physics. So 10 kg is clearly a scalar, right? It has involves only magnitude, correct? Work done is a scalar, and here 10 kg also a scalar. Okay, like mostly these terms will be repeated in physics concept. Anyhow, okay. Next, and before that, I'm going to represent a vector graphically. For that, I'm going to take x-axis, y-axis means directions. If you want to represent a vector graphically, we want to know the direction east, this and this is clearly west, this is north, this is south. You should take like this, and depending on the question, for example, if you see that this question is there, yeah, this question, represent graphically a displacement of 40 kilometers. Like see here, every vector is represent, like look at here. This is actually a vector from O to P. O to P, like O is the initial point, starting point, P is ending point, that is called a terminal point. Actually, this is give a vector. Vector nothing but the displacement from one point to other point. Okay, so instead of the term vector, they have given displacement here. Represent displacement, represent graphically a displacement of 40 kilometers, 30 degrees west of south. First, of south means from south to west side, it is 30 degrees. West of south, west of south. In the same way, here they are taking scale is 10 kilometers. Okay, in the same way, there is a one question in first exercise. Represent graphically like displacement 40 kilometers, same 40 kilometers, but in that question, west of south they have given, but here east of north, same kilometer. East of north, from north, we can take a 30 degrees. Yeah, this is clearly 30 degrees. This is, look at here, east of north. Okay, starting point is O. This ending point is P, that is terminal point, and this distance is 40 km. So here we can take scale is 10 km. 10 km. Same. So 30 degrees of east of north. That's all. So first you have to take the direction like east, west, north, south. You must be take as it is. Don't take in place of east is north like that. Okay. This is the graphically. So represent a displacement of 40 kilometers east of north, right? And coming to the next question. I'm going to explain you the concept of uh, I think I already explained that initial point, the terminal point. Yes or no, students? Right. Once again, I'll revise the concept. To take the vector, it must be have a starting point, it must be have a ending point. Starting point I'm taking as A, that is I told you very clearly. What is the other name of starting point? Initial point. And ending point is called a terminal point. Terminal point. So like see here, in which direction from A to B. So here AB will give is a vector AB. When I write this symbol, arrow symbol, this arrow symbol will represent a direction from where to where? A to B. A to B. So A to B. If I write simply here AB, what is the mean by AB? AB nothing but it is a distance from one point to other point. So that is nothing but this is called magnitude. If I write the arrow symbol, then it will represent a vector without arrow symbol AB, nothing but it will give a magnitude. Magnitude. This magnitude is also can be written as like AB, this is also can be written as modulus of R AB. Okay, so AB vector modulus R is equal to AB, or this is called magnitude. Magnitude always a real number. Magnitude is always a real number. But every vector having a direction as well as magnitude. Fine. So here A is called initial point, B is called terminal point. Now I am going to discuss about uh, co-initial. What is the mean by co-initial vector? Co-initial vector. Anyone? The vectors are said to be co-initial vector. That vectors must be having same starting point. Like I'm taking this is vector A, this is vector B. What about the starting point, initial point? Initial point is same. Terminal point is different. If I take capital A here, capital B, with capital C I'm taking. AB vector is I'm taking as small a vector, AC vector I'm taking as small b vector. If you observe these two vectors, ending points are same for both the vector, but starting point is same. So this A and B are called co-initial vector. Next, co-terminal vector. Co-terminal vector. So what is the mean by co-terminal vector? Terminal nothing but ending point. The starting point is same for initial point, same is that co-initial. Terminal point is same, like this is starting point, this is ending point, and this is starting point, this is ending point. Okay, when I take here the vector, like this is vector A vector, this is vector B vector, this is starting point A, ending point is B, starting point C, ending point is D. So finally, here terminal point is coincide. Okay, so given two vectors coincide at B, then terminal point is same. So that these A and B are called co-terminal vector. Co-terminal vector. Now coming to the next important point is that like collinear vector. Collinear vectors. So what is the mean by collinear vector? Collinear vector means, simple student, the vector which are parallel. The vectors which are parallel, we can say that collinear. I'm taking the vectors like this. Okay, I'm going to take first vector is vector A, this is vector B, this is vector C. Three vectors are there. What about A, B, C? A, B, C, all three are parallel. I'm not saying that the direction, whether the vectors are parallel or not. Okay, direction is not important here. Direction may be here if you see that A and B are opposite direction. But collinear means whether parallel or not. That's it. You have to check whether parallel or not. And B and C. Okay, direction opposite direction but parallel. When you see A and C, okay, same direction and parallel. So here A, B, C are called collinear. But if I take any other vector like this, vector, this is D vector. What about vector D? Vector D is A, B, C and D are collinear? No. A, B, C alone collinear, D is not collinear because D is not parallel to any one of the vector. Okay, here A vector, comma B vector, comma C vector are only collinear. Means parallel. But how to represent mathematically? So vector A can be written as lambda times of B vector. And this is equal to some mu times of C vector. Every vector, for example, I'm going to give example for the two vectors. Like vector A, I'm giving I plus J plus K. If I'm taking vector B as, okay, you can multiply any number with this vector A. This I plus J plus K with a given vector A, I want to multiply with 10. 10I plus 10J plus 10K. After multiplying 10, I'm taking as vector B. Now what about these two vectors? So vector A and B are parallel. Parallel nothing but one vector we can represent lambda times of other vector. That is nothing but, shall I write here, B vector is equal to, if I take 10 common, I plus J plus K. Nothing but what you observe, this I plus J plus K is vector A. See here, vector B, I have represent some lambda times of A vector. Or B is equal to vector, you may write like this also. Vector A is equal to 1 by 10 times of B vector. Now this is also in the form of lambda. You can represent any way, 10 into A vector or 1 by 10 into B vector. So 1 by 10 is also a real number, so that when we represent one vector lambda times of other vector, then both vectors are parallel. When two vectors are parallel, we can say that collinear. Collinear. Okay. Now, next, coming to the equal vector. Equal. Equal vectors. What is the mean by equal vectors? Yes, students. Equal vector means, simple students, the vector A and B is said to be equal vector. Like if I take vector A is like A1I plus B1J plus C1K. This is B vector is A2I plus B2J plus C2K. Now, the component, the corresponding component must be equal. That is nothing but A1 is equal to A2 and B1 is equal to B2 and C1 is equal to C2. That's all. When the corresponding components are equal, then we can say that equal vector. Equal vector. Got it? Equal vector. This is about the equal vector, right? Okay, for example, now I'm going to discuss one by one. And for example, if they give any vector, vector A like A1I plus B1J plus C1K, I want to find the magnitude of A, magnitude. So when I want to, this is modulus nothing but magnitude. When you want to find the magnitude, simply A1 square plus B1 square plus C1 square. Got it? So then this is the magnitude of the given vector. In case if they ask like any magnitude, you can do like this. Now, coming to next one is a unit vector. Very important concept is unit vector. This already you studied in physics. All this you already studied in physics in class 11. Am I right? So what is the mean by unit vector? For example, I'm taking this is B is the V vector. In this direction, I want to know just a unit distance, 1 unit distance. I think so. I already explained this unit vector also for you. So V unit vector can be denoted by A cap, that is vector A by magnitude of A. Got it? Yes or no, students? Clear? Fine.
Sir,
Now,
could you explain equal vectors one time again?
yeah, the corresponding scalar component must be equal. When I equating these two vectors, I coefficient, j coefficient, k coefficient must be same. Like you can see here. What about I coefficient here? A1. What is I coefficient? A2. A1 must be equal to A2. And what is the j coefficient here? Here B1, here B2. So B1 must be equal to B2. K coefficient is C1. Here C2. C1 must be equal to C. Then only we can say that two vectors are equal. We can say that in another way, same magnitude or support, a same equal magnitude and the same direction. The two vectors are said to be equal vectors. The two vectors which having same magnitude, okay, and same direction, in same direction. Got it? This is about unit vector. Now, I told you very clearly, collinear means parallel. Co-initial means starting point is same. Now, according to that concept, anyone can say that what are the co-initial vector in this given figure 10.6? It should be a square. Square nothing but all sides are same. Yeah,
Sir,
anyone?
A vector and
A and
D.
exactly. See, a starting point is same. A and D are the co-initial vector. Fine. Co-initial vectors are A vector and D vector. Like equal vector. What are the
Sir,
equal vectors?
D and B.
Yes,
D and B.
D and B. That is, we are saying that B and D. Why can't we take like vector A and C?
So they're in opposite directions.
Exactly. So vector A in towards right side and it is towards left side. Opposite direction. So we can't say it is equal. Now collinear but not equal. Yes, collinear.
Sir, A and C.
Right?
Now A and C. Because if you take B and D, that is equal, but they are asking collinear, but not equal means A and C. A and C are parallel vectors, so that we can say collinear. Right. Coming to the next one, answer the following as true or false. Very simple question. Collinear I said. Okay, for example, look at here, students. If I take the this is vector A, If I take opposite direction like with 180 degrees, this will give minus of vector A. Opposite direction is like if you take any vector AB, this can be written as minus BA vector. Got it? AB vector is equal to minus BA. In the same way, here if I take AB vector as A vector is equal to, like, in opposite direction, when we change the direction with 180 degrees, like opposite direction will give minus A vector. Nothing but, see here, what about this vector A and the minus A vector, collinear or what?
They're
Collinear or
collinear.
not? Collinear, nothing but what?
Parallel.
Yeah, what about this vector A and vector minus A vector, minus of given vector? Parallel. Maybe direction is opposite. Direction is opposite. This is vector A. This is vector A. Yeah, this is vector A, and this is vector minus A. Okay, minus of vector A. Nothing but parallel. But direction is different, but parallel. So that this is true. What about this? Two collinear vector always equal magnitude. Two collinear vector always equal magnitude. When I take here ABC, what about ABC? Is here ABC are having the same magnitude? Like length is same from starting to ending point here. Is it compulsory that the magnitude is equal? Not necessary. Collinear means I said just parallel. They may having different magnitude. For example, if I take this is vector A, I'm taking vector, this is vector B. Okay, this vector is 2 centimeter, I'm taking here 10 centimeter. Magnitude is different, 2 centimeter, 10 centimeter, but two vectors are parallel, so that collinear. Okay, right, this is false. Coming to the third, two vectors having same magnitude are collinear. Is that correct?
True, sir.
Two vectors are having same magnitude. Can't we say that it is a collinear?
No, sir.
It is not a collinear. See here, just they mention same magnitude. But if I take different directions, 2 centimeters only. Here also I'm taking same 2 centimeters. This is vector A, this is vector B. Now easier the same, these two are having a same like parallel. Yes. Is there A comma B or parallel? No. Magnitude is same as for this like vector A, vector B. These two are vectors as well as same magnitude. Can we say that these two vectors are collinear? No, because these two vectors are not parallel. This is false. Then what about the fourth subdivision? Two collinear vectors having the same magnitude are equal. True. Yes or no? Is it true or not? Yes. Badmasharan. Students, anyone?
So true, sir.
Is it true?
They're not true. They can be in opposite directions.
Yeah, that is important. That is important. See here, two collinear vectors having same magnitude. Magnitude same, nothing but, see, I'm taking in this direction, I'm taking in this direction. So magnitude is 10 centimeters, 10 centimeters. But is there equal? Equal nothing but what? It should be same direction. But they have mentioned just same magnitude. So that not is false. Only first one is true. Okay, next coming to next exercise. I hope that what about the first? What are the question we completed in this exercise, students? Just tell me that. Anyone? Yes.
So complete
First question they
6.
asked me. Yes. Completed sixth one. Fourth one. No one is responding. Only 1 or 2 persons.
Sir, we also completed a 5.
5. Yeah, just wait. Yes. Yeah, anyone? Delin? Yes, Delin? Ritvik? Ritvik? Mithun? Yeah, Mithun. Don't you know what are the questions we completed in previous class? Yes, Tarun? Yeah, what I asked the question? Girls? Only Kishore is responding. Okay, so first question, magnitude nothing but they asking magnitude, so square root of I coefficient 1 square plus 1 square plus 1 square. Here b means magnitude of b is equal to root of 2 square plus minus 7 whole square minus 3 whole square. Like that, in the same way you can find magnitude. Once again, I'm repeating. Here different direction having same magnitude. Same magnitude means a vector is equal to I plus j minus 2k. Now b vector is equal to uh, 2i plus j minus k. These two are the example, and you write the different vectors having same direction. Same direction means you should not be change the sign. Just take any vector, multiply with 2. Like I'm taking vector, this is the vector. Just multiplying with 2. This 2a vector, 2a vector I am taking as b vector. Same direction means signs should not be changed. Now coming to here, find the value of x and y. Given two vectors are equal means, okay, comparing both the vectors, x is equal to 2, y is equal to 3. Coming to the fourth one is find the scalar components and vector with initial point and terminal point is given. When they given starting point and ending point, starting point here, what is the starting point here? Starting point here, 2 comma 1, and ending point is minus 5 comma 7. Here first scalar components. The scalar components are given by simple. The second minus 5 minus 2, comma 7 minus 1. So that is nothing but x2 minus x1, y2 minus y1. So that is minus 7, comma 6. These are the scalar components. And coming to vector components is clearly minus 7 into I cap comma 6 into j. That's all. Okay. x2 minus x1, y2 minus y1 are the scalar components. Along with I and j, that is called vector component. And coming to the sixth question. Sixth question also I think I explained. So addition, sum they asking. Adding a plus b plus c, value you need to find. And coming to the question number 7, a unit vector in the direction of the vector I plus j 2k. A given vector I'm taking as already given, I think so. Yeah, they only given I plus j plus 2k. It's very, very simple, students. See, unit vector formula is a cap is equal to vector a by its magnitude. Given vector by its magnitude. Okay, first I'm going to find the magnitude of the vector that is square root of 1 square plus 1 square plus 2 square. Okay, 1 square plus 1 square plus 2 square. So this is equal to root 6. Root 6, its magnitude, now substitute here. Unit vector a cap is equal to I plus j plus 2k by root 6. That's it. You may write it separately, 1 by root 6 into I cap plus 1 by root 6 into j cap plus 1 by root 6, sorry, 2 by root 6, maybe k cap. That's it. This is the required a unit vector. This is required unit vector. So unit vector can be denoted by cap, a cap, b cap, c cap, like that. Okay, procedure will be like this. Now, coming to the next question, question number 8. Find the unit vector in the direction of PQ, where PQ are the points. Okay, very simple, very simple. Like P is there, 2 points they have given here, P and Q. We need to find here the vector PQ vector. P is starting point, Q is ending point. P is clearly 1, 2, 3, 4, 5, 6. Right, when initial point and terminal point is given. Now, what the question they are asking? They are asking about the vector, unit vector in the direction of. Unit vector means, simple students, we can do in 2 ways. We can do is 2 ways. One is with help of the point like x1, x2. So now here PQ vector is given by x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Got it? Now substitute the values here. When you substitute the values, 4 minus 1 into I cap plus 5 minus 2 into j cap plus 6 minus 3 into k cap. So finally PQ vector is given by 3i, 3j, 3k. Is it clear, students? This is the required vector. This is one way, method 1. Method 2 is we have to take the position vector. Position vector like
So shouldn't I be minus 3? Because x2 is minus 4.
oh, is it minus 4? Yeah, it's not a minus 4, it is plus 4. I have written like 4, 5, 6 only. Okay, Kishore?
Okay, sure.
Yeah, in another way, yeah, what is the position vector of the point P? Position vector. Method 2. First, find the position vector of the point P that can be written as OP. Simply that is I plus 2j plus 3k. And in the same way, Q also given here, Q also given. A position vector of the point Q can be denoted by OQ, that is equal to 4i plus 5j plus 6k. Okay, after getting OP and OQ, then we want to find the PQ vector. PQ vector is equal to OQ vector minus OP. That's it. As simple. So this is equal to OP minus OQ. Sorry, OQ minus OP. 4i minus I. 3i plus 3j plus 3k. 4 minus I, like 5j minus 2j, 3j. 6k minus 3k, 3k. So again we got the same matrix, PQ. So this is the method 2. Find the position vector. Position means whenever if I mention that position vector, initial point must be the origin. See here in both the cases, When I take here, this is O, this is O. Starting point is clearly origin, then ending point is the given point, then we can say that that is a position vector. Got it? Position vector, right. But here the question is, we have to find the unit vector. Unit vector of PQ vector. Already we got PQ vector, then how can you find the unit vector? This PQ vector I'm going to take as vector A. Then unit vector of PQ is PQ nothing but what? PQ is equal to, I'm taking as vector A, is A cap is equal to vector A by magnitude of A. Yeah, all of the students, you can try to find this. Do it fast, just a minute. Okay, ma? Right.
Sir, could you explain how we found the values for OP and OQ?
Yep. Okay, right. OP means just whatever the point they have given. What is the point they have given here?
They for P they've given 1, comma 2, comma 3, and for Q they've given 4, comma 5, comma 6.
Yeah, when P is 1, 2, 3 means 1 into, simply you can take like this. 1 into I, 2 into J, 3 into K. Here Q is clearly uh, 4, what is Q? Yeah, Q is 4, 5, 6. 4 into I, 5 into J, 6 into K. Nothing but, I'm taking position vector of the point P is OP. The meaning of that is, when I take the initial point, starting point O, and this, for example, P, 1, 2, 3. So origin is 0, 0, 0. This is O, this is P. I want to know this vector, position vector of the point P with respect to O. Now this is x1, y1, z1. This is x2, y2, z2. Just now I have written one formula, x2 minus x1. Somewhere I have written. When they have given two, yeah, this formula you have to use. This x2 minus x1 into I, y2 minus y1 into z. Like that, when I use that, we are going to get OP vector. OP vector is x2 minus x1, 1 minus 0 into I, 2 minus 0 into j, 3 minus 0 into k. Nothing but same, I plus 2j plus 3k. Got it? Mostly we'll write directly. Okay,
Okay, sir.
right. Now what is the answer? You got it here. You can do this. Then you can find magnitude of this, then substitute here, you will get the answer. We will get it. 27 will get root over 27, that is 3 root 3. 3 minutes more for us, like let us do this question number 9. Question number 9 also, see student, first we have to find a plus b. What is a plus b here? Some of the a is given, b is given. A plus b is I plus j get cancelled, 2k minus k plus k, that's it. I plus k, this is a plus b, this is equal to, I am taking vector c, some c vector, a plus b is equal to, I am taking c vector. They are asking a unit vector of a plus b, nothing but unit vector of c. C cap is equal to vector c by magnitude of c. Means vector c nothing but I plus k, magnitude is root over 1 square plus 1 square, that is I by root 2 plus k by root 2. This is the answer for this question. You can do this question. Coming to 10th one. Yeah, now find a vector in the direction phi I minus j plus 2k, which has magnitude 8 units. 8 units. Magnitude already is given 8 units. Right. Any vector see here. For example, a cap is equal to, it can be written as vector a by magnitude of a. Am I right? But I want to know just vector a alone. For this, magnitude of a into a cap. Just cross multiply this. This you can cross multiply. We'll get like this. Then what do you observe here? Any vector is given by magnitude into unit vector. Magnitude into its unit vector. So in coming to here, when you observe here, question number 10, magnitude already given 8. Magnitude already given 8. So that is nothing but, if I consider this vector is as a vector A, okay, vector A, like let 10th question, take the given vector. Vector A is equal to phi I minus j. Okay, students, we'll continue this class. You no need to leave the meeting. You are in the meeting. You can take 10 minutes break. Okay, no need to rejoin. I